I have this data frame df that I made in the previous video, and that contains an x value and a y value, and I secretly know that this y value, it follows some quadratic equation in terms of x, okay, plus some random noise. And so what we did in class was we used a for loop to add in some column called x1, that's the first power of x, a column called x2, that's the second power of x, and so on. And we did that a bunch of different times. Let me show you a more elegant way to do that using an object or a class from scikit-learn called PolynomialFeatures. So I'm going to say from sklearn.preprocessing import PolynomialFeatures. And you're not going to need to know this for the midterm in Math 10, but knowing how to use polynomial features, it'll be a good review for using anything else in scikit-learn, like especially standard scalar. The syntax is going to be exactly the same as for standard scalar. So I'm going to say, first so here I imported. Now I'm going to create one of these polynomial features objects. So I'm going to say poly equals polynomial features. And in here, I'm going to say what the degree should be. So maybe I'll save this so that if I change it later, it's a little easier. I'm going to say maximum degree I want to consider is 6. And so here I'll just say degree equals max deg. Okay, perfect. And so we've done the import, we've done the instantiate. Next, we want to do the fit. So I'm going to say poly.fit. And then I'm going to say df, and then I'm just going to fit the x column, and let's see what happens. And this is like the most common error I get related to scikit-learn. So this error, it is saying I gave it a one-dimensional pandas series, but it wants a two-dimensional data frame, even if that just has one column in it, still wants it as a data frame. Okay, so I'm going to have these double brackets here so that what's going inside the outer brackets is a list. And now that error went away. Good. And now if I do poly.transform, and then I need to put in this same thing, dfx. And let's see what the shape of this is. So if you remember, what's the shape of this dfx column? Okay, that was length 1000, or sorry, this dfx data frame, I should have said. This is 1000 by 1. And so what this is doing is it's putting in powers like degree 2, degree 3, and so on. But let's just look at the top. So let's just look at the head of this. And I guess I have to convert it into a data frame. So let's say pd.dataframe, because the head part wasn't going to work if it wasn't a data frame. And so what I want you to notice is, for example, here I have, let's see, this is probably the best one to look at. Here I have negative 0.2. Okay, then here I have negative 0.2 squared. Here I have negative 0.2 cubed, and so on. But there's also this negative 0.2 to the 0th power over here on the left. And so I'm gonna get rid of that. So how can I get rid of that? I can come up here and I can say include bias equals false. Okay, so this bias is like saying, do we want a constant term? And so here I'm going to say, no, I don't want that constant term. Okay, and then if I run these again, and let's delete that one. Okay, so now it's starting at 0.2, negative 0.2, then negative 0.2 squared, negative 0.2 cubed, and so on. Okay, and notice that the numbers up here, they don't represent the degree. So we'll have to change that in a minute. So let's get a list of all of these degrees. So let's use f strings, and let's say xi for I in range 1 to max degree plus 1. So this will be 1, 2, 3, up to and including 6. Okay, and let's call this COLS for columns. And I want to put these powers into the data frame, into the original DF data frame. Well, that's nice and easy to do the way I have it set up here. I can say make these 6 columns with the names x1, x2, and so on. And what do I want to put in there? I want to put in this polynomial transform. Okay, so this thing that contains the first power, the second power, and so on. So let's look at the head of the data frame. So here's my x, here's my y that secretly follows a degree 2 polynomial. Here's x again, x squared, x cubed, and so on. So this is going to be a good data frame for performing polynomial regression with.